Hello and welcome everyone. Please ensure you like and subscribe to my YouTube channel for your more detailed civil engineering courses. Probably you must have heard about limit state design because almost all design codes employ this method. Codes like BS code, IS code, Euro code, and the likes. So what is limit state and what is limit state design? You see, limit state is defined as a particular state in which a structure ceases to fulfill the functions for which it was designed. So, what is the function or what are the functions at which we design a structure for? There are two in number. We design it for durability and also we design it for safety. These two they work hand in hand. So you don't just get the architectural drawing of a structure from the architect and start constructing like that. No, it is dangerous. You need to design that structure first to ensure it will be durable and safe for the occupant. So the second part here is the state. So we've known the functions at which we design structure for. So what are the states that we affect the function of our structure? So these states they include deflection, bending, cracking, shear, buckling, corrosion, torsion, abrasion, and total collapse. You see, these states are the states that render a structure unfit, and they are the limit states that we are so concerned about. So these aforementioned are the limit states. So as the name sounds, limit states, they are the states that will limit the durability and safety of your structure. Alright? So however, some of these limit states will affect only the appearance of the structure, while some will affect or they will cause partial or total collapse to the structure. Some will affect just the appearance, while some will cause partial or total collapse to the structure. So if it affects only the appearance, it means the structure will still be of service to us, although it is unsuitable. Okay, so let's separate them and classify them based on how it affects the appearance or the nature of its collapse. So if it affects only the appearance, we will label it as A, but if it will cause a collapse, partial or total, we label it as C. So these are the limit states. They are 9 numbers, and then their effects on the structure. These are their effects on the structure. So if it will cause a total or partial deflection, total or partial collapse, you see it as C here. But if it only affects the appearance, you see it as A here. So that's how I label it. So the first one is deflection. Deflection will affect the appearance. Remember, when you are doing the analysis of a beam and you calculate the deflection of a beam, deflection is always in millimeter. It's around 0.2 mm, 0.5 mm, 0.75 mm, something like that. Deflection is always minimal, something you can really see with your eye. So it will only affect the appearance, not collapse. So deflection will affect the appearance. The one about bending or flexure. Bending or flexure, this is when the bending moment is high at the support. So this is a partial collapse. So what about cracking? Cracking will only affect the appearance. Nothing will occur to your structure when it is cracking. It's only cracking. So shear, of course, shear is a failure. It's a total failure. It's a total collapse. So it is C. Buckling is also a collapse. It is C. Corrosion, this is when the steel reinforcing, then the steel reinforcement is rusting. So that is, it only affect the appearance. Nothing will occur. And what about torsion or twisting? As it sounds, twisting. Your beam is twisting. Of course, it is collapse. Then abrasion or wear. Abrasion, it is only appearance. It will affect just the appearance. Then total collapse. Of course, nothing to argue here. It is collapse. Collapse is collapse. And that will take us to the types of limit states we have. You see, there are two types of limit states. One is limit state of serviceability, and the other is limit state of collapse, or you call it ultimate limit state. You see, limit state of serviceability, these are the limit states that will only affect the appearance of your structure. Limit state of collapse, these are the limit states that will cause a total or partial collapse to your structure. So these are the two types of limit state. So if I want to reclassify them now, that means under limit state of serviceability, I will have deflection, I will have cracking, I will have corrosion, I will have abrasion. Under limit state of collapse, I will have bending, I will have shear, I will have buckling, I will have torsion, and and now we have total collapse. Alright, so now that you know what limit state is, we shall now discuss limit state design. You see, limit state design is a kind of design which aim is to ensure that the structure does not reach a limit state. You understand? Limit states are the states that will make your structure to be unfit. Then limit state design is the kind of design that we ensure that these limit states do not occur. Just like you are designing for the limit state not to occur. So that's limit state design. Before the arrival and acceptance of limit state design, there was working stress design method, also called the elastic design method, and there was load factor design method, also called the plastic design method. Let me show you a section to explain this method. So these three beams sections are designed using different design method. This first one is designed using working stress design method. This center one is designed using a load factor design method, and this last one is designed using a limit state design method. So let's discuss them one by one. The first one, which is the working stress design method, if you look at the beam that was designed using that method, it has a high section. Look at the section, it is 450 by 600 mm. And high section, that will be uneconomical because it will take a lot of concrete for you to cast this beam, because it is 450 by 600 mm, so it is uneconomical, although it is durable. So simply what I'm trying to say is, when you're designing using the working stress method, it will result in high cross section, although it will be durable. So you can say it is uneconomical but durable. So the second design method, which is the load factor design method, you can see the dimension, it is 150 by 600. This is so slender and it cannot be durable. It won't be durable. When a load comes on it, it just deflects. So when you're designing using the load factor design method, it will result in a slender cross section which will not be durable. And this is the third beam, which was designed using a limit state design method. You can see the dimension of the cross section is 300 mm by 600 mm. So I can say the dimension is the cross section is appreciable, therefore it is not uneconomical and it is durable. So it makes a blend between working stress method and load factor method. So that is why limit state method is the most appreciable design method. Remember that high cross section is uneconomical because it takes a lot of concrete to cast it. You may be thinking that wow, this method is so cumbersome. If I want to design just a beam, do I need to design it for deflection, cracking, corrosion, abrasion, flexure, shear, buckling? No. You don't need to design them for all these limit states one by one. So you just need to design for the most critical one, and in the process, the less crucial ones will be satisfactory. This is what I mean. For instance, if a beam wants to shear, it will do so in the following process. First of all, it will start cracking from the bottom to the top. Cracking will take place. That's the first. Then the second process, it will start deflecting a little bit. It will start deflecting, and gradually it will be twisting. That's torsion, and then finally it will shear. The most critical limit state here is shear. Therefore, I can just design this beam for shear. Alright, so you don't need to design it for cracking, deflection, twisting, and shear. No, just design it for shear, and in the process, the rest will be taken care of. Alright, so and one more thing, while designing the structure with limit state method, the load combination used is the design ultimate load. That is the load corresponding to the ultimate limit state, not the load corresponding to limit state of serviceability. That is the service load. No. Meaning we design for limit state of collapse, but not limit state of serviceability. We don't design for limit state of serviceability. However, we check if limit state of serviceability is satisfactory or not. So this is why you can design for shear, but you can only check for deflection. You don't design for deflection, you only check if deflection is satisfactory or not. But you design for shear by choosing the appropriate diameter and spacing of your stirrup. Remember, I explained it in one of my previous videos that the main function of stirrup is to prevent shear failure. So you can design for shear and you just check for deflection. It means we design for limit state of collapse and we check for limit state of serviceability. So thanks for watching my video up to the end. Ensure you like and subscribe to my YouTube channel. Thanks for watching.